Hi guys, some of you might have noticed while I've been playing Elite Dangerous recently, I've been having some problems with the EdTracker software. Well, not so much troubles, but my particular MPU, the head tracking gyroscope, has been very random. It's been tracking very badly. So I've actually dug in around about the code. I've modified the code, put in an extra little subroutine at the end that does things. Well, the main one does diagnostics and temperature compensation. Temperature compensation seems to work pretty well, and it does seem to stabilize the gyroscopes quite a bit. Although I think my gyroscope still. It's a bad chip, I think, because its calibration characteristics have always been wildly different from the settings you would see on any other screenshots. I'll just plug it in now, and I'll show you what happens when we do so. So USB connectors at their best. It was upside down. So we'll give it a few seconds to be detected, and we'll connect. Now if you look at the temperature up here, you'll see it started at about 24 or something. I've recently just unplugged it to allow it to settle down in temperature basically, but it's going to rise up. Now I've set a temperature of 40 degrees as its end point for the temperature, and if everything goes to plan, the software will kick in and stabilize the temperature. Now the way I've got this working is I've created a circuit inside. Well, I've put some software inside that controls a pin on the chip which switches a transistor on. So I've added a transistor and added two resistors. One of the resistors is used as a heater that's, in my case, I've arrow-dated it straight to the top of the actual sensor. I just turned down that other computer. So what it does is basically the processor sees that the chip is too cold, and it will then put power through the transistor, put power through the resistor, and heat it up to 40 degrees, which is where we're getting now. So in a few seconds you'll probably see it stops dead at 40 degrees, give or take 0.01 typically. Now this is coming on from cold pretty much, so it's came up from about 20 degrees. It's been unplugged for about 5 minutes. But you'll see the temperature there. Now the circuit just fell off the desk and landed on the floor. I love it when things like this happen. Let me just recenter that. Right, okay. So, notice that the temperature went down when it landed down there, but you should see it compensates itself back up again in a second. So the temperature tends to stay pretty much accurate. You'll see here that the temperature is always just wobbling just a little bit, and that does introduce a slight amount of yaw drift, but the yaw drift over a more than a sort of 1 or 2 second period is dramatically reduced as the temperature is fixed at the right point. Let me just pick it up from the floor here. Right, so I've now picked it up. Now this is the circuit board on its own. If I blow on the circuit, the temperature will drop down. The LED that normally just flickered once a second is actually, I've configured that so that it's actually showing when there's a heating element in action. So it's on 100% at the moment. Now it's started flickering and it's gone into I'm going to call it pulse width modulation. It's not quite pulse width modulation, but it's basically flickering on and off very rapidly to demonstrate that it's heating and cooling continually. just to allow it to go back to the normal temperature. Same thing happens here if I spray the chip with some, what is this? This is contact cleaner. So the temperature will drop dramatically. And in this case it stopped at 27-ish, didn't it? And it's now, the circuit's basically fighting back, trying to heat the transistor up again, or heat the resistor back up again. Once it gets back up to about 39.5 degrees, it starts going into a sort of pulse width type operation, and then tries its best to hold the temperature at 40. It does vary a little bit. It's like 39.99 or 40.01 sometimes. But I think the most important thing is that it is stable once it gets there. The best way to ensure it has a bit of stability is to put the circuit inside a box, or what I've done to give it a bit more heat mass is actually I've temporarily just threw or stuck a lump of blue tack on top of the actual chip and the resistor. By doing that, the resistor now also needs to heat up all of the blue tack and whatever it's in contact with, and that means when a breeze or anything drifts by, it has to cool down everything, so it gives it a bit more stability. So you can see we've got back up to 39.99 again, and the light started flickering on and off. It's pulsating at about 100 times a second, so it's literally just constantly monitoring. And you can see the temperature is, as far as it's concerned, rock solid. I'll just put my finger on top of the chip. So now my finger's on top of the chip. So the temperature, it feels quite warm to touch. You notice the temperature will go down until it reaches my sort of skin temperature, basically, give or take. They'll come to a sort of middle balance, and then the temperature starts to rise. So it's working exactly as expected. I'll just take my finger off that again because that's pretty warm. So this time it's heating up quite hard there. It might overshoot slightly, but it should come back down again. So 40.02, so it fixes itself and comes back to 40. And that's it back into that high-speed switching mode, basically. So this has basically allowed the stability of this thing to become much better. If I just stick it to the desk with some blue tack so it doesn't move around too much. If I reset the tracking, you'll notice that with the compensation it's in at the moment, it's actually off in the other direction, exactly the same amount. So if I save drift compensation, the compensation figure is calculated as nothing. This chip basically seems to be an awful lot more solid. You see it is wandering around about 0.6, 0.8, and it'll go 0.9, usually comes back down again. So 0.7, 0.8. So the compensation, as it gets a chance, it will settle down and it becomes pretty much solid. It's nice experimental code. Seems to be making this chip a little bit more stable, and this is a terrible chip. If I excuse me, just press the right button. If I bring up an Explorer and go into the tracker and go into sketches, and if I load up my own calibration system, I'll just take this offline for a second and upload the calibrate. Okay, so that looks like that's uploaded. So I'll connect back to it, and the EdTracker will change to the other screen. Look at the readings I get on Gyro X. 1728. You notice that the temperature went down when I reprogrammed it, because the program wasn't, the heater wasn't running while it was reprogramming, so obviously it cooled down again. So my Gyro X has always been way out. It compensates relatively well, but I do get a lot of wandering around on the compensation. With this circuit in place, it seems to be performing a lot better. You'll see it's still actually trying to settle down to the 40 degrees. Maybe we'll get there. So this chip also has a lot of problems with the acceleration X, Y, and Z, but it's mainly that Gyro X that's always troublesome. I'm just going to wipe the data from the chip. That throws it back to the wildly random numbers. I mean, just look at this for Gyro X. Whenever I see anyone else with these numbers, they're usually sort of down in the 50s or 100. But not on this one. So I'm just going to recalculate the bias values. And this is one of those chips that is mentioned on the EdTracker videos, that basically it takes multiple hits to actually get to work. So you'll see here it's only put 195 calculate bias in, whereas it actually needed an awful lot more. So that's 390 now in, and it needs an awful lot more. $585, still needing an awful lot more. The number in the Gyro X needs to be about 1800. The calibration circuit, well, this calculating bias values eventually gets there. The one problem with the calculate bias values constantly is that the temperature does drop slightly in that process, as while it's calculating I can't run the circuit to heat. So once it gets up to temperature, it actually starts dropping off slightly while you calibrate. Usually proves not to be too much of a problem. It only drops very slightly. And then if you really need to, you could potentially tweak the last 1 or 2 digits, but it doesn't seem worth doing. As you can see, this chip is eventually starting to get to the right points here. It's taking a long time to calibrate. It's us probably closing in on about the right number. It's going to stop about 500 there, so give it another hit. $1560, so I'll stop just under 200 or about 200. There you go. See the temperature had dropped off slightly. That's because I was repeatedly hitting the calibrate, so it just throws the calibration just slightly. So we'll wait for it to warm up again. That's close enough. So 1723, that's getting close to the correct sort of numbers. So you can see here I've got pretty much green on everything. It's close. Now you notice that the gyro X on this particular chip drifts. That's partly in time with the temperature heater coming on and off. The micro heating that goes on does drift the X gyro. But the X gyro on this particular chip is really not good at all. So it needs an awful lot of compensation fixing. On a better quality chip you don't see that drift. Nowhere near as far anyway. So this is going to be 6 screens by the looks of it. That's the correct settings here. You'll see gyro X is still wobbling around a little bit. But the main advantage with it is that it will stay solid, it will stay secure as you as the room warms up or the room gets cooler, because the chip itself is actually self-compensating. So that was the calibration process. That's the chip pretty much now calibrated. So instead of running the calibrate, I'll run the program which does the actual temperature calibration, the actual proper chip itself, the final code for the joystick effectively. Oops, I'll need to disconnect that and upload again. So uploading, uploaded, and connect. This is one of these times where the chip doesn't reload. That's a fairly common problem with this system. Maybe every so often you hit the program button and it just simply doesn't work. Nah, it looks like it's going to hang out again. No, that's it, trying now. Okay, it looks like it's connected up and done the program that time. Or has it? Got to love these demonstrations when they go wrong. I've just unplugged the USB and replugged it again. Right, the chip seems to be running at the moment, so we'll just try connecting. Nope, this is one of these moments, isn't it? The chip's just not happy. I'll try hitting the program again. I don't even know what port it's on at the moment, I've not checked. Looks like it's on a different port. Yeah, I couldn't find it on the selected port. Right, let's close that down again, reopen it again. Tools. Yeah, this is... if you watch the video where the guys from EdTracker actually describe this circuit, this is something that he says sometimes can happen. You'll hit the program button, it'll just do nothing. So I just unplugged it and replugged it back in again. We'll reload the software, and this time it's come up as COM5. Right, we'll try programming it again. Right, so I can see the chips responded this time. So the programming's been done. The chip is now in the process of running, so the temperature should have dropped away as it was unplugged, etc. And it should come straight back up again and stop at 40 degrees again. So temperature stability is good. I've got the chip currently blue tacked onto the desk so it doesn't wander or move around. So let's set it up in the normal way. We'll do all of this lot. We'll reset the tracking if we press the right button. And we'll look at the drift over a period of time. So that's been approximately 1 minute of time went past there. We're now at yaw drift of 0.29 and still dropping slowly as it just takes its chance to settle in. So that's 2 minutes in, the yaw drift is at 0.26. I think I'll just stop at that. I mean, obviously if you leave it for longer, the calibration, it will eventually settle in a little bit tighter. But we'll leave it at that and we'll save that drift compensation. And the chip saves that setting, and then the yaw drift comes back to basically a rock solid green. Obviously, because I reset that only after about 2 minutes, it may tend to wander a little bit as time goes on. But it gives this circuit modification and the programming seems to give it a much more solid calibration. So I'm going to play around with this for a little while, see how it goes. I've got more chips arriving, more 6050s and 90, whatever the other one is. So I've got those arriving as well in the next few days, week. And we'll test it with others. If it proves to be good, what I'll do is I'll release the code back to the original authors, and they can implement that code if they wish into the system. The code has no influence on the original software, so you can choose to either fit the resistor and transistors or not fit the resistor and transistors. It doesn't make any difference. If we disconnect a heater, the system still works just the same. The only difference is the code will be constantly trying to push heat through the heater, which doesn't exist, therefore no power consumption, no anything. So you can see here the drift has moved up very slightly again. That's because its compensation value is dropping as the system is still settling. So if I just resave that again, it's going to give me a slightly more accurate setting again. So that's what we would do. Or ideally we would do that over a longer period of time for the first reading. But yaw drift compensation inside EdTracker with some custom code seems to work quite well. Hopefully it will prove to be good. It will prove to be useful. Thanks for your time. If you liked this video, please subscribe. Please leave a comment below. If you do leave a comment, when I do add another video along these lines, I will reply to your comment so that you will be informed of the changes. But thanks for your time. It's been an awful long video, but I think it's possibly been useful. Thanks. Have a good day.